Hello, and thank you for tuning in to this discussion of Problem 15 from POA Textbook Chapter 5. Problem 15 builds on Problem 14. And let me remind you that Problem 14 basically dealt with an optimal RQ policy, as usual, given certain demand and lead time information. And what we're looking at here is what we found in our analysis of Problem 14. And so specifically, we found a cost minimizing value of Q of about 81, an alpha of about 96, and that resulted in a total cost of $190. So this is our starting point for the discussion for Problem 15. In Problem 15, we're basically being told that we're sort of questioning the validity of our assumption for the backorder cost at $10. Remember, it is very difficult to estimate the backorder cost because it varies so much from one situation to another, from one customer to another. So for example, at an extreme, I might encounter a stockout and I will then choose to not return to the store for a year, for example, in which the stockout cost is significant. On the other hand, the stockout cost could be such that while I choose to upgrade to a higher margin product, in which case the backorder cost would be negative. So that's what I mean by the difficulty we encounter when we try to quantify backorder costs, because there really is no easy, in any shape or form, straightforward way of estimating what this backorder cost is. Not in a given situation, and certainly not on average across an entire customer base. So here, this is the case. In other words, we are questioning whether it is really reasonable to assume a backorder cost of $10. Now we're taking away this backorder cost information. Remember, when we don't have complete information, of course, we cannot really optimize. So what we're doing instead is reverting back to what we call a managerial policy. And remember, we call it a managerial policy because in the absence of complete cost information, again, specifically the backorder cost information is missing here, we need to managerially define a service level. And so here we are being told that we're looking for a 90% in-stock rate. Specifically, the question says we want to make sure there is no stockout in 90% of all order cycles. So this implies a 90% in-stock rate. And we're being asked to calculate the associated values for the order point of Q and the reorder point R. So let me simply set alpha equal to 90% as requested in the question. Now really the last thing I have to do to answer part A of question 15 is to simply recalculate Q. Remember, the value of Q we're looking at here, well, that's the Q we obtained through optimization. In other words, this value of Q is based on our knowledge of the backorder cost P. So now that we don't have that, we've taken that out of the question, we need to redefine our cost minimizing order quantity Q. Remember, all this means is that we revert back to our basic Q. So I will recalculate Q as the square root of 2 times annual demand times the order placement cost divided by the holding cost per unit per year, which is H. So that gives me a Q of about 75 units. Again, alpha, as requested, is 90%, which corresponds to a safety stock of 18.43 units, and thus a reorder point of 109 units. And that will be the answer to part A of question 15. Just a brief note on these total costs that you see down here. Remember, of course, it would seem as though our costs have decreased relative to the optimum. Remember, in the optimum scenario that we calculated in problem 14, total costs were $190. So is it true that with the solution costs have decreased? Of course, the answer is no. The costs have simply decreased because we are no longer able to calculate backorder costs because of this missing value of P, the backorder cost per unit. So in other words, we are no longer able to rely on the calculator estimate total costs. So we really want to ignore all these cost calculations down here. Now the only thing we can assess would be cycle and safety stock holding cost, as well as order placement costs. Now let me turn to part B of question 15. And part B says, we erroneously identified or defined a type 1 service level of 90%. Really what they wanted is a 90% fill rate. In other words, a 90% type 2 service level, beta. And the question simply is, what is the fill rate actually achieved when we define the policy as requested in part A of the question? Well, this is easy to answer. In fact, I can just read it right here. You see the fill rate obtained with a Q of 75 and an in-stock service level of 90% is equal to a 99% fill rate. Now, I want to briefly extend Part B of question 15 and also figure out how would we redefine this RQ policy if we wanted to, in fact, obtain or achieve a 90% fill rate. Now, this is actually quite easily done, but clearly, if a 90% in-stock rate results in a 99% fill rate, then I will need to lower in-stock rate to achieve this lower desired fill rate of 90%. So, of course, I would go ahead and just plug in a number of values. For example, let's say I set alpha equal to 60%. You see, I still have a fill rate of 95%. So alpha tells me that I stock out in 4 out of 10 cycles. But when I stock out, I don't stock out by much, which is why I have this high fill rate. Now again, we could keep playing here, but I can ask Excel Solver to find that one value of alpha that will actually result in a fill rate of 90%. So I'll set up my Excel Solver here, and let me reset all this. What I really want here is I want to set my objective function equal to beta, and I want to make sure that I get a beta of exactly 90%. So I want to set the fill rate equal to a specific value of 0.9 by changing the value of alpha, the type 1 service level. That's really all I have to do. I click on Solve, and now you see if I have an alpha, an in-stock rate of exactly 41%, then I will achieve a fill rate of 90%. That was apparently what was really desired when we switched to a managerial policy. Now notice, just as a note of interest, with an alpha of 41%, we are actually getting a negative value for Z, a negative safety stock. Well, in fact, it really is because, remember, the reorder point is the sum of two components, average lead time demand and safety stock. And having a negative safety stock simply implies that my reorder point is actually less than average lead time demand, so I will stock up even more. So I delay order placements, and that does effectively lower my average inventory holdings. And that's why I have a negative safety stock here, a negative safety stock holding cost. Again, think of this negative value simply as an adjustment to the cycle stock holding cost. So this answers questions 15A and B, and in addition, we define the managerial RQ policy for a given fill rate or type 2 service level target of 90%. Thank you for listening to this video, and please tune in for problems 16 through 18. And that resulted in a total cost of $190. So this is our starting point for the discussion for problem 15. In problem 15, we're basically being told that we're sort of questioning the validity of our assumption for the backorder cost at $10. And that resulted in a total cost of $190. So this is our starting point for the discussion for problem 15. In problem 15, we're basically being told that we're sort of questioning the validity of our assumption for the backorder cost at $10.